Hello, everyone, and welcome to the Grove. My name is Hawk, and today is another episode of my Trickster tutorial series. This tutorial helps you learn the Trickster mod for Minecraft, and as you might see in the background, I had to extend my build for this one. So, my building is bigger. I have a bigger house, one which has an actual classroom, which I will start off the episode by actually showing off, because I like how I made it. So this is the lovely build that I created. I decided to design it like a classroom because I wanted to have sort of like a blackboard thing, furniture piece, to represent when I need to just have a blank background to put text on and help me explain concepts. So I added this. And so, because one of the reasons that I need to have a background for this episode is because today we're talking all about numbers, addition, subtraction, but mainly how do you read this number system? The number system in the new updates, because it can be a bit complicated. So the first thing you need to know about the system is that it is an octal system. So unlike in base 10, where you have 10 digits, you have 0, 1, 2. Well, in the decimal system, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you have 10 digits. In an octal system, it is a base 8 system. So you have the digits 0, 1, 2, 3, 4, 5, 6, 7, and not 8. Because 8 gets you a second digit. So you just have those 8 digits, and the whole number system is based off of those digits. And so when you go into your wand to write them, you'll end up with something that looks a bit like this. So, where it's this sort of circle with a little window, little split in it, and then you'll have this divider pin that marks, hey, this is the spoke, this is the number that this is representing. And this whole divider pin, which I call a spoke when we're referring to the digits, then that's just helps you know what value, that's the word I'm looking for, value, that it's sort of representing. So this one represents 2, and then if you add to it, so if you move it up and you add to it, you can get things like 4. So this is 4. So moved over to 2, because you go from 2, 3, 4, and you go over here. But if you multiply 4 by itself, and I'll go over these different mathematical expressions, you will get, well, first we actually need to times this, so yeah, you will actually get 8. Now, 8 has 2 digits, so it is not of the main ones. So it has 2 circles. So the number of circles is the amount of digits in the octal system the number has, and then where the spokes are in the glyph, that's what indicating the value that individual circle is supposed to represent, which can become a bit confusing, because what if you're representing something like 10, which would be written as 12 in the octal system? Well, let's look at what that would look like. Behold, this is 10. Well, 12, but representing the value of 10. As you can see, this is over to the right because it represents the number 2, but instead of being at the top where one might, well, actually it would be over here, but instead of being over here where the 1 would maybe go if that's what you're expecting when you're just writing it out for the first time, it's actually down here. That's because the spoke of the inner circles, the inner circles represent, like, adjust basically the next circle up. So since this is the 1's place, it is affecting the 8's place. So, but if this is where the 0 is on the 8's place, this is where the 1 is for the next digit up, And that's, of course, where we find our 1, 8. So you have the 1, and then you have the 2, which makes the value of 10 because we're representing the number 12 in the octal system. And this does continue up. So if, say, we use 10 and we go to the power of itself, if we square it, we get 3 rings because we're representing 100. Now, 100 has 64 in it. It has one singular 64, and then after that, you get 60. No, I was about to do incorrect math. It is 36, which is left over. So you have to break it down into that 36. So you have the 36. So you have the 1, which is the 100 part. So you have 164. Then you have 0 left over after 0. That's what I'm getting right. So the innermost is 4. And then the next one, because the zeroths, the top of the next digit is at the bottom, that means the 4 will be at the top. But of course, since that resets us back to the top, that's where you get the ones place. So the number we're looking for is 144 to represent 164. Then you have 4 8s to make 32. And then you have 4 left over because you need 6. So here you go. Here it is. You got your 1, 4, and 4. So it clearly, even someone as me who has been studying this for a bit, it can be a bit tricky, but you get faster over time. As you can see, I probably only took like a minute maybe to fully decipher this and quickly do it. I'll probably leave in that full thing because I think I was talking out loud during that. So that's how you represent numbers, is that you pay attention to the spokes and how the spokes are rotating, and then you get the number. Now, when numbers are written in vectors, so this is going to be I'm about to convert this into a vector. So you got your x, y, and z. And when I convert it into a vector like this, where it's just from downmost up to the top, and then you make like this triangle shape, you get this. So this is how vectors are represented. You have your x, y, and z. And it just goes from x in the bottom left and then just around the circle. And this is how vectors are represented. So, and then each number in this circle is just represents each different number glyph. So it's like a smaller glyph contained in itself, which I think is cool. I personally like how they're doing the glyph system for the numbers. It's just really cool. It took me a moment to learn. I actually had to bring out a sketchbook and be like, what in the world is going on here? Because I couldn't figure out, because it's not listed in the tome anywhere. None of these digits, I believe, are listed in the tome. I admittedly didn't look far into where it is, but I just figured it out. I'm like, oh, this is an octal system all on my own, which is cool, because that means I don't know, I just really like it. And then realizing like how it was turning around, that was cool. Although it was funny to try and prepare something about a scroll, like an episode about scrolls, and then get jump scared by this sort of thing. And I'm just like, what in the world am I looking at? Because I was using a vector. I was doing something like basically how you do, let me see like the block I'm looking at. And I get something like this. I didn't know how to read this, but now I do, theoretically. So you can imagine my surprise, which is why I wanted to create this episode, is because before I wouldn't know how to read this, but now I know it's something that would take me a while to decipher, but I theoretically could do it. Like, I know in the bottom for Z, I know it is what it is. Let's see. Let's see, that's a 5, and that'd be 55, which would equal... Why is it 55? Which equals 40. That's a 5. That's a multiplication of 5. Why was I failing at that? Anyway. 40 plus 6. It's 46. When I'm not failing at math, it's easier. I even chose the easier ones of this, and I still failed. Moving on. Point is, so I hope that helped understand what you're seeing on screen when you're trying to read numbers. So you just sort of do it backwards, where it's just like, okay, the innermost. I was just going backwards, and I even used a calculator to help me when I was having a hard time translating, especially if it's something like a number. But at least when you're starting out, feel free to use a calculator. I don't think anyone should be ashamed of that. Additionally, there are videos online. I checked. I've recorded this. This is actually a second attempt of me fully recording this episode. I know there are other videos online that can help you read an octal system, so you can look at those for if you need any help on trying to read the numbers. But at least I hope that I gave you some understanding of sort of how the digits operate. And for now, I'll also give you sort of like a picture on screen so you can screenshot it of all the different digits. 0, 1, 2, 3, 4, 5, 6, 7, and 8. I'll just throw an 8 in there for fun. So here's a screen. Here's an image, which is going to screenshot. And this next part of the video will just teach you some basic arithmetic. So now that you know how to read numbers generally, let me tell you how to manipulate them. At least some basic ones that I've been using most often. These are not all of the ones in the arithmetic section of your book, because if you look at your guidebook and you go to distortions and stratagems, which are under tricks, so you go to tricks, distortions and stratagems, and arithmetic. If you want, you can add a bookmark up in the upper left, and then you can just scroll to whatever ones you want. So if you do, so annexation is the addable one. So you have this sort of start from the bottom, go to the center, go up to the right, go up to the right, or up to the left. Either works when you're not trying to fail at using the thing. And then go up to the topmost without going to the center. Just hook around, back to the center. And then if you hit the button that allows you to execute, to evaluate, then it will add the numbers together. But of course, I have nothing in the arguments, so it won't do anything. And the thing about the annexation revision is that it will go in sequence. So you have 2 plus 2 equals 2. It equals 4. 2 plus 2 plus 2, this will equal 6. And sure enough, that's what we got. So we got 2 plus 2 plus 2 all the way to 6. And now what if we wanted to, like, minus 2? Well, we can do that with the, I don't want to, desertion stratagem. So, or the subtract one. So you just basically do it, but reverse. So it's upside down. So you start from the top, go down to the middle, down to the left, down to the bottom, over to the right, and then back to the center. Or, of course, go down from the top to center, down to the right, hook over to the left, and then back to the center. Then you press evaluate, and you'll get your 4. Because 6 minus 2 equals 4. We're very elementary right now, but these are the basic concepts. And then you can multiply as well. So just like with the addition, and in the subtraction also works where you can minus things after each other. So if you, for example, you know what, let's get back to 6. This will get us back to 8. Let me get back to 6 for a moment. There we go. So I'm going to get back to 6. So I'm just going to add these together. So we currently have 6. And then now, if we want to get, say, let's actually start with division, because that's how we can get to the number 3. So so this is multiplication. So this will get us to 12 if we do this. So this is 12. So you have, no? It is 12. This is just 14 because it's 2 more than 10. It's represented by 14 because you have 1 8 plus 4 equals 12. And so you have 14. This is 12. And if you divide, so if you multiply by 2, and say if you want to, so then you can just divide by, so it's S for if you want to multiply, because it is the domination stratagem. So let's multiply. I'm sorry, I have no real good way to remember these other than just memorize. The S one looks like the multiplication system, and the Z summation one looks like a Z. So you have multiplication, and then you have whatever, or you have the division, so we can go back to 6. But then multiplication, it acts like the addition, where you can actually, as well as division acts like addition as well, in the sense that it can take multiple arguments, where like the first one, it's like, okay, here's a number, and then it will divide by this number, and then it will divide by this number. So if we have 12 divided by 2 divided by 2 again, will get us to 3, if I did this correctly. And it did. So this is 3. So you have, because it would be 0, 1, 2, and then of course 3. So, and then if we wanted to go backwards, so if we add this over here, and write the S, so this would be multiplying, so it'll go 3 plus 2 plus 2, that'd be 3 to 6 to 12, represented by 14. So it can be helpful to keep those in mind. Also, you can actually add vectors together as well. I've been actually using, when I was originally learning the mod and I was using it to make teleportation, that's how I ended up adding to, like, getting more of the length. And then, so if you want to add, and so you can multiply the distance of like where you're facing. I don't know a quick way to show that to you guys in this video. And I will go over that when I work with vectors, but you can even see in the book itself that addable and subtractable are either numbers, vectors, or patterns. And then multiplicatable and divisible and roundable numbers are only numbers or vectors. So, and roundable is like, oh, you have 1.5, let's round that up to 2, for example, because there's 1 for that. But you could minus 1 from a vector to make let's say you want the y to go down, then you can just have it 0 minus 0. Let's say you want to, instead of something being at your feet when you cast it, but you want the reference to be at your feet for insert reason here, you can have it where it's 0, 1, 0 added to whatever coordinate you have. Let's say 102, 63, 78. Then you can easily do that. So you can have it 102, 64, 78. So you can add those together to just help you with whatever you're trying to do. So I hope that all made sense. And quick thing. One easy way to get a larger number that I find helpful is just taking the 2 and you can provide export, like exponents. So you have 2 and then in a moment I'll go over like how do you create 0 and how to create 1, because those are probably would be useful. Exponent. This is exponent of, this will create 4, and this is actually the exponent. So this will be 2 times 2 times 2 times 2, because it's the exponent of 4. So this is the, I believe it's called the supremacy. Yes, it's the distortion of supremacy. So basically it treats the first number, second number, as the exponent to the first number. But unlike the division and division, multiplication, those ones, unlike those glyphs, the actual, this only has 2 arguments. So it has the first one and then the second one. So it's just this contained variable, because otherwise it will just not fully understand what the third one is there for. I believe that's how it's written. Yeah, so you have turns the first number to the second, and it just won't work if there's a third one in there. Because you can try. I didn't expect that to work. So the number we got was 20, which is 16. It just, oh, it's 16, but it just didn't take the third number. It just threw it out. It just like, I don't know why you're there, so I'm going to put you in the trash bin. That's what happened. So yeah, there you go. That's how you use the exponent factor. And there's a bunch of other things in the arithmetic section. So if you want to take a look, you can. There are things like here's what to round, here's what to play around with. But that'll be, and when you do use it, you'll probably want to know how to like what numbers you plug into the like arithmetic thing. But I hope this one at least helped with you understanding how you can get to larger numbers, help you read the numbers, and just some like basics of how numbers work in our little system that we've created. And I just realized I almost forgot. But before I do my little outro, let me quickly go over before I forget. How do you get to 0 and 1 using the math? So you have your 2. And then if you divide by 2, you get 1. And then if you subtract by 2, you get 0. And of course, if you want to say you have a number in the center as like the end result of something. For example, if I wanted to use this 4 as maybe I'm trying to, I don't know what the word is, not quadruple, but whatever the exponent of 4, whatever that's called. I'm going to look it up now because I'm curious. Cube or squared, but 4. hypercube or tesseracted. So if you want to tesseract something and you need the 4, but you need it in an above space, you can use this one, which is the Ascension revision? No, it's split. I looked it up, it's actually called the split. So when you do this, it'll, which you've probably seen me doing this entire tutorial, it is just, it basically moves whatever circle you have into the subcircle. It helps with moving numbers around, and then, so that'll help. And then of course, the extension one, just to create new circles. So for the split one, you can either start from the left to the top left, all the way down to the bottom right, or you can start from the bottom right up to top left through the center, and then down to the left, and then it'll just poof, it'll move. Unlike the other ones where it's doing calculation, it automatically does it because you're manipulating the scroll, the revision. You're revising the spell itself, not trying to specifically cast the spell to get some sort of result. So, yeah. And that's where I'm going to leave off today's video because I had a lot of different concepts and I don't want to overload information. So we're going to end it here for now. Feel free to put anything down below if there's something you want me to cover. I do have projectiles on the list as one of them. So if you're thinking about suggesting it, maybe you either A, suggest something else, so I have more things on my priority list, or B, just ask something specific about projectiles. Like, hey, how do I get this projectile to X thing? Like, how do I add velocity? Or how do I manipulate a vector so it's not just coming from myself? Those are things that I need to actually work on so I can actually get to you. So I probably will do vectors actually first, just to review, and so that you actually understand what's going on when we're working with vectors, and then I will be going over slots so that you understand slot references, and then we can actually work on vectors, on projectiles, because without having a basis of those two things, those two concepts, you'll find projectiles very confusing. So those are probably my next two videos I'm going to prioritize in this series, so that when you actually go to work on projectiles, you understand what's going on. But if you don't know how to read the slot numbers or understand how vectors look and how to read them, how are you going to understand what those are? So I hope this gave you more of a better understanding of what vectors look like and how to read them. And yeah, hope you have a good day, night, whatever time it is for you, and goodbye!